Welcome, innovators, to the Idea Mechanics Lab. I'm your navigator, and today we are firing up the forge to craft a seriously powerful tool for your innovation arsenal. We're going to talk about the art of seeing trouble coming and designing it right out of existence. This is beforehand cushioning.
For way too long, innovation has been kind of stuck in this reactive loop. We wait for something to fail. A screen cracks, a server crashes, and then we all scramble around asking, okay, how do we fix this? But the TRIZ approach, as you can see right here, it just flips the script entirely. It pushes us to ask a much smarter question. How do we design this thing so that failure is basically impossible? And that's the huge shift we're exploring today, moving from simple repair to building in true resilience from the start.
That leads us straight to the core of TRIZ Principle 11, having a proactive innovation mindset. It's all about building that resilience, that preparedness, directly into the design from day one.
So the official name for this is beforehand cushioning. The idea itself is simple, but wow, is it powerful. You anticipate potential failures and shocks, and then you literally build a protective cushion right into the design. It's about engineering the harm away before it even gets a chance to happen. So let's be super clear about our ultimate goal here. This isn't just about making things stronger in the old-fashioned sense. The real goal is to design these elegant systems that can absorb shocks and neutralize harm so well, the user might never even know there was a problem in the first place.
Okay, so how does this actually work in the real world? Well, let's zoom way in, down to the microscopic level, with a piece of tech you almost definitely have in your pocket right now. We're going to break down how Gorilla Glass completely solved that unbreakable screen problem.
For years, phone designers were stuck with this classic engineering contradiction. We all wanted these beautiful, sleek phones with thin, lightweight screens. But we also wanted those screens to, not shatter when we dropped them on the concrete. And traditionally, making something stronger meant making it thicker and heavier.
So this created two totally conflicting demands. On one hand, requirement A, make the screen thin and light because it looks good. On the other, requirement B, make it incredibly tough to survive our clumsy everyday lives. These two goals just seem to be in a total standoff. How could you possibly get both at the same time?
Well, the solution is just pure chemical genius. Instead of adding bulk, engineers used beforehand cushioning at a molecular level. It's a process called ion exchange. So get this. The glass is put into this hot, molten salt bath. That makes the smaller sodium ions leave the glass. This opens up space for larger potassium ions from the bath to squeeze into those empty gaps. And because these new ions are bigger, they're packed in there super tightly, creating this invisible, high-stress cushion right on the surface.
This pre-stressed layer is the molecular cushion. So when an impact makes a tiny crack, this built-in force immediately pushes back, stopping that crack dead in its tracks. The contradiction is totally solved. We get incredible strength without adding a single millimeter of thickness. Amazing, right?
So it's a fantastic solution on the atomic scale. But does this whole idea of beforehand cushioning apply to bigger things? What about the huge, complex systems that run our entire digital world?
Oh, absolutely. The same principle scales up beautifully. So now we're going to go from atoms to architecture to see how this system cushion protects the critical infrastructure that powers pretty much everything we do online.
In the world of data centers, financial networks, and telecom, failure isn't just a little inconvenience, it can be an absolute catastrophe. We're talking millions of dollars lost, essential services disrupted, even a few seconds of downtime is a massive deal. Here, reliability isn't just a feature, it is the entire foundation of the business.
And this is where system-level cushions are absolutely mission-critical. To absorb the shock of, say, a power outage, data centers use huge power cushions, uninterruptible power supplies that kick in within milliseconds. But what about when a piece of hardware fails? Well, for that shock, they create a data cushion. Your data isn't just on one server, it's instantly mirrored to another one. If that main server goes down, the system automatically fails over to the backup so seamlessly your video stream doesn't even have to buffer. The failure gets completely absorbed by the cushion.
Okay, so we've looked at atoms and we've looked at entire data centers. What's the big idea we need to walk away with here? It's really about adopting a completely new mindset for how you design things.
So what's the blueprint you can use in your own work? First, make proactive thinking your default. Always be trying to get ahead of problems. Second, plan for the unexpected by embedding these cushions at every single level, from the materials you choose to the systems you build. And finally, always remember the real goal,
Move beyond just solving problems and start creating a state of permanent operational preparedness.
I want to leave you with this final thought. The best innovators, they don't just cross their fingers and hope things will go right. They systematically and really cleverly design systems that are resilient enough to absorb the absolute worst-case scenario. So the question for you is, where in your world can you start building a cushion?